Now we will continue one more video to explain the conductivity of weak electrolytes. So one more law is there, that is called Kohl-rauch law. Kohl-rauch law of independent migrating Kohl-rauch law of independent migration of ions. Kohl-rauch law of migration of ions. So what is the statement of Kohl-rauch law? There are various definitions are there. Okay, the simple definition is the limiting molar conductance, the limiting molar conductivity of an electrolyte, at any electrolyte. Limiting molar conductance means, what is the limiting molar conductance already you know. The molar conductance at infinite dilution, the molar conductance of an electrolyte at infinite dilution or zero concentration is called limiting molar conductance. Limiting molar conductance, limiting molar conductance of any electrolyte or an electrolyte the limiting molar conductance of an electrolyte is equal to the sum of algebra, the sum of individual concentration of the cation, sum of the individual concentration of the cation and the anion of an electrolyte. Anion of electrolyte is called limiting molar conductance. Lambda m naught is equal to lambda m naught C plus cation, lambda m naught A minus. Minus means cation. Here C plus means C means cation, anion. Or if you take an electrolyte here, AB is an electrolyte, A plus and B minus. That means A plus and B minus. The limiting molar conductance of an electrolyte is equal to the sum of the individual concentration of the cation and the anion of the electrolyte. That means here the limiting molar conductance for any electrolyte is equal to the summation of individual contribution of cation and anion, both sum of the cation and anion. For example, now I am taking here lambda m naught molar conductance at zero concentration or infinite dilution is equal. For example, now I am taking here electrolyte NaCl, lambda m naught Na plus and lambda m naught Cl minus ion. The limiting molar conductance of an electrolyte is equal to the algebraic sum of the individual concentration of cation, individual concentration, the equivalent individual contribution of concentration of cation and anion, not concentration, contributions. Not here. This is contribution. Individual contribution of cation and anion. For example, if you take one more example, you take BaCl2, barium chloride, lambda m naught Ba plus 2, lambda m naught Cl minus. How many Cl's are there? 2 Cl's are there. That's why now I am taking here 2 Cl minus 2 lambda m naught Cl. For example, if you take one more example, lambda m naught calcium chloride is there. The limiting molar conductance of an electrolyte is equal to the sum of individual contribution of cation and anion. This is lambda m naught, cation here Ca plus 2, 1 cation, plus lambda m naught Cl minus how many is there? 2 Cl's. Like that, if you take one more example, molar conductance at zero concentration, or limiting molar conductance of an electrolyte. Limiting molar conductance means not only at zero. If you take lambda m power infinity, infinite dilution, the conductance of an electrolyte to infinite dilution, lambda m naught Al2SO4 taken thrice is equal to how many aluminiums are there? 2 aluminiums. 2 into lambda naught m Al plus 3 plus how many sulfates are there? 3 sulfates. 3 into lambda naught m SO4 minus 2. Okay, this is the one statement, or one more definition also is there. This is based on the molar conductance. If you take equivalent conductance, also one more statement is there. Okay, you can observe here. Based on the molar conductance, limiting molar conductance of an electrolyte, based on molar conductance, one statement is there, and equivalent conductance also one more statement is there. The equivalent conductance at infinite dilution, yeah. Okay, based on the before formula, based on the lambda m molar conductance. Now equivalent conductance. Now I am taking here based on, there are two statements of Kohl-Rauch law of infinite independent migration of ions, based on the molar conductance, based on the equivalent conductance. Okay, based on the equivalent conductance at infinite dilution of an electrolyte is equal to the equivalent conductance at infinite dilution, the equivalent conductance at infinite dilution of an electrolyte is equal to the equivalent conductance at infinite dilution of an electrolyte is equal to the algebraic sum of equivalent conductance of an anion, equivalent conductance of anion or equivalent conductance or mobility of anion and cation. Equivalent conductance or mobility of ion, of cation and anion or anion and cation is called Kohl-Rauch law. Kohl-Rauch law of independent migration of ions. The equivalent conductance at infinite dilution of an electrolyte is equal to the algebraic sum of equivalent conductance of an ion and a cation. Okay, that means here you can observe lambda not equivalent conductor at infinite conductor, that is electrolyte is equal to, if now I am taking electrolyte AB, equivalent conductance for cation C plus or plus, here plus, here minus, A plus and my B minus, like that, equivalent conductance. That means here electrolyte means here nana lambda naught EQ. For example, if you take lambda naught EQ AB, lambda naught EQ A plus, lambda naught EQ B minus. If you take first example, lambda naught EQ NaCl, I am taking electrolyte, lambda naught EQ Na plus plus lambda naught EQ Cl minus ions. In case if you take one more example, calcium chloride for equivalent conductance. This is only one cation and one anion. If you take a second one, equivalent conductance of calcium chloride is equal to equivalent conductance Ca plus 2 plus equivalent conductance only Cl minus but not 2 here. And also, if you take one more example, equivalent conductance lambda naught EQ Al2SO4 taken thrice is equal to equivalent conductance Al plus 3 plus equivalent conductance naught lambda naught equivalent conductance SO4 minus 2, but not here number of cations and anions. In case this equivalent conductance can be converted into molar conductance. Little bit difference is there here. Okay, what is the relationship between equivalent conductance and molar conductance? Already you know formula. That formula is for example equivalent conductance given, how to convert. For example, CaCl2 is there, then can be converted into molar conductance Ca plus 2 and molar conductance of Cl minus. Okay, actually relation here, equivalent conductance lambda EQ is equal to lambda m by n factor. Actually, what is the formula relation between lambda m into lambda EQ into n factor, charge of ion or cation ion? Here lambda EQ is equal to lambda m by n, where n is the n factor. You take salts, charge on cation or anion. Here what is the charge here? Plus 2. Plus 2 means here by, okay, what is the here 1 by 2 lambda m naught Ca plus. Here only minus 1 charge lambda n naught Cl minus only. If you take one more example, how to convert equivalent conductance to molar conductance. For example, Al2SO4 taken thrice. that is equal to lambda m naught aluminum Al plus 3. How many aluminiums are there? 2 aluminiums are there. That's why here only by 3, charge by 3 plus lambda m naught sulfate SO4 minus 2 by 2 SO4. Only charge is by n. Okay, this is 1 by 3 lambda m naught Al plus 3 plus 1 by 2 lambda naught SO4 minus 2. Okay, this is applicable for only weak electrolytes. Okay, now this is information about Kohl-rauch law of independent migration. Okay, now applications of Kohl-rauch law. What are the applications? The first one, it is used to calculate equivalent conductor molar conductance, limiting molar conductance of a weak electrolyte. Limiting molar conductance of weak electrolyte. Weak electrolyte. How to calculate the equivalent conductance of weak electrolytes, sir? For example, now I am taking weak electrolyte. Equivalent conductance of H plus. How it is calculated, sir? Okay, now I am taking some by calculation here strong electrolytes. Lambda m naught CH3 COONA sodium acetate plus lambda naught HCl minus lambda naught NaCl. Lambda naught, you can ions, lambda naught Na plus ion plus lambda naught H plus lambda naught Cl minus minus lambda naught Na plus or minus minus lambda naught Cl minus. Lambda naught Cl minus plus lambda naught Cl minus minus lambda naught Na plus gets cancelled. Okay, then finally lambda naught CH3 COO minus lambda naught H plus. Okay, this is the one of the application to calculate the weak electrolytes. And second application is, if you take one more example of this one, if you take ammonium hydroxide also, one more example, NH4OH, equivalent conductance of NH4OH is equal to NH4 plus equivalent conductance of OH minus ions. Okay, here now I am taking a strong electrolytes lambda naught NH4Cl plus lambda naught NaOH minus lambda naught NaCl. We can observe here, okay, dissociate into ions here, NH4 plus lambda naught Cl minus plus lambda naught Na plus lambda naught OH minus ions minus lambda naught Na plus minus lambda naught Cl minus. Cl minus plus Cl minus gets cancelled. Less NaCl minus NaCl gets cancelled. Lambda naught NH4 plus ion plus lambda naught OH minus ions. This is the weak electrolytes. Okay, it is used to calculate the equivalent conductance or limiting molar conductance of weak electrolyte. Limiting molar conductance or limiting equivalent conductance of electrolyte. And second application here is used to calculate degree of dissociation or degree of ionization. It is used to calculate the degree of dissociation of weak electrolytes. That is equal to alpha degree of dissociation symbol lambda MC by lambda M naught. That means molar conductance at infinite dilution at zero concentration, molar conductance at any concentration by molar conductance at zero concentration or infinite dilution. And third one is it is used to calculate the solubility of sparingly soluble salts. It is used to calculate the sparingly soluble. Calculate the solubility of sparingly soluble salts. Like example here, silver chloride or barium sulfate, etc. Okay, what is the formula of here? Solubility S is equal to K into 1000 by lambda M naught. This is the formula of solubility. And finally, it is useful for the calculate the dissociation constant of weak electrolyte. Fourth one is it is used to calculate the dissociation constant K is equal to C alpha square by 1 minus alpha. K is equal to C alpha square by 1 minus alpha. This is called dissociation constant for weak electrolytes. Okay, these are the applications of Kohl-Rauch law. Thank you one and all. Okay. In case you like this video, please share and subscribe my channel. Thank you one and all.